Let me make sure I'm getting volume. Dang it, volume. Help. Where? Hello. Test. Microphone check. Microphone. Where's my sound? Whoops. Um, Come on now. Okay. Microphone. Yeah, we're good. Okay. Oh, let me get on the first browser that I made to see the thermal camera image. This just it's a outside program that lets me see the thermal in a bigger window, the factory Sense XOR view that I had to use to send the thermal data to the Arduino Uno Q. It would not expand. So this is it. This shows the temperature of my body. This is not the temperature inside my room. It has a orientation control. Uh, it has a hot state. So if I grab this beverage right here, it's nice and cold and black, stick it in front of the camera, it will, it shuts off my lasers, but it doesn't say it's cold. There's something in the program that I haven't had time to get to, but um, there's different palettes, rainbow, all pixel sharp. So yeah, that looks pretty cool. Peace sign. All right, we'll get out of this one. Uh, unconnect. Okay. Anyways, we'll exit out of that one. We'll open this, and this is the Arduino code. It is still, let me just test it real quick. Turn this on. Okay, it froze. 1 second. Oh man. Refresh, connect. Now moving. This one has contour, so it takes those pixels and it averages the temperature. But we're in Celsius. Let's move it to Fahrenheit and high. Not filtering. Anyways, so yeah, all the colors. Doop, 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 mm. I like that one probably the most. Yeah, nice and purple. Okay, so let me explain this code in the serial monitor. 1 second. Okay, so far for this project, I'm going to walk you through the Arduino Uno code. It works together with the ESP32 thermal camera firmware. Uh, if I block these lasers, it says it's supposed to be alarm on, or come on now. Well, anyways, Let me just exit out of that and try again. Alarm off. Well, it worked on my other video. I'm sure I have to like reboot the code or something. Anyways, that shows the status. The lasers are on. I can do a test and make the lasers do some crazy sequence. That looks pretty cool. I can do cold, and it'll turn them off once it gets through that. Yeah, so cold. It's supposed to turn them off. The temperature is incorrect. Hot turns it on. There's also a calibration feature for the hmm, yeah, they're not reading the values of the photocells. Anyways, let's just collapse this then. Thermal's still working. So starting with the Arduino, um, the top of the code, I define the GPIO pins right here. Each of the three lasers are connected to digital input pins, 2, 3, and 4, and the photocells are connected to analog inputs, A0, A1, and A2. This setup keeps the system simple. The Arduino just reads the analog values from the photocells and turns the lasers on or off. And then there's serial communication, uh, void loop. The Arduino constantly listens for types of input. One is from the USB serial monitor for testing, and the other is from the ESP32 over universal asynchronous receive transmit UART that's handled in this loop function right here. So basically, it's always checking for commands, updating the system state, and monitoring the photocells. And then the thermal trigger logic. Um, Somewhere right here. When the Arduino receives a temperature message, it processes, or from the ESP32, it processes the handle temperature line function. And the system turns the lasers on when the temperature crosses a threshold. Um, so that means the lasers turn on at about 78 degrees Fahrenheit and turn off at about 76 degrees. There's some conversion in there. This creates a small buffer so the system doesn't rapidly switch on and off. Laser activation, when a hot condition is detected, Arduino calls a function that turns the lasers on. It also resets the photocell system and prepares for new detection. Photocell calibration, you can hit cal, and it will calibrate the AO, the analog input photocells over here. For some reason there's zeros and stuff. They're supposed to be like in the thousands. Um, and this is important because lighting conditions can change, so we need a reference point because detecting or before detecting anything. And then the intrusion detection logic, C control F, apps, photo, oops, so delta trigger right here. Um, After calibration, the Arduino continuously compares live photocell readings to a baseline. If the difference exceeds the threshold, it assumes a beam, and the beam has been disrupted. To avoid noise and or false triggers, the system requires multiple consecutive detections before triggering the alarm. Um, and then the alarm behavior, when the beam is interrupted, the system enters an alarm state. Um, you know, it says that in that state, it stays in that state until a beam or all beams are clear again from a certain amount of time. Uh, so it's not just reacting instantly, it's making sure the conditions are real. Um, ESP or the ESP32 side is over here in VS Code. Oops, collapse that. Well, this is the UART bridge, the final form. Uh, Now on the ESP32 side, I modified the firmware, the factory firmware, to process the thermal image data and send useful information over a receive line. There's no writing. That's basically UART, but just the TX comes from the ESP32, and then whoops, right here, and then yeah, it goes to the it talks and then it receives to the Arduino. Anyways, it reads raw pixel data from the thermal sensor and converts it into temperature values. It scans through the image and finds the hottest regions on the body, it tracks it, calculates an average temperature of those regions, of those pixels. I like that signal processing stuff. Contour detection is what it's called. Instead of using the entire image, the firmware basically focuses on a contour and the hottest cluster of pixels and helps filter out noise and focus on actual heat sources like a person. And there's hot and cold detect decision. The system determines whether the scene is hot or cold. Where is that? Define thermal contour hot. Right here. The 76 and then 70, that's our cold off. This uses hysteresis so the system doesn't flicker between states. There's a UART output, temperature, whoops, somewhere. Yeah, 0.5 F. Um, it's actually a pretty long. Well, anyways, maybe it's on the yeah, temp 78.5. The max is 80.2 pixels, 120 state hot. It's somewhere on here. Anyways, the Arduino reads this and decides what to do next. The message includes temperature, max values, number of hot pixels, and the system state. System integration, bringing it all together. The ESP32 detects the heat and sends a signal. Um, yeah, I can try that again. Well, it doesn't really matter, but you can tell that it's blocked off by my bottle of Coke. Arduino receives a signal, activates the lasers, uses photocells. It detects if any of the beams are interrupted, it'll tell me if beam one, beam two, or beam three. And then uh, just this approach combines thermal sensing with optical detection. I just really like thermal imaging. They use it in like substation diagnostics and like autonomous systems for like reliability with thermal and a mixture of red, green, blue, like real life visual stuff. They use it like in combination. It reduces false triggers, improves detection accuracy. Um, so that's basically it on the code. And I guess is there anything else? Show some more of the palettes. Rainbow. That's basically it. Do. Thank you for watching. Dang it. Stop share. Stop record.